Hello, everyone. Welcome to the webinar hosted by UReason. I will start now with the webinar. There's still people coming in, but I'll start because we have a tight schedule. It's a short webinar. It's a new type of series that we're doing. And in this short webinar, I will take you through a number of ways to reduce the time spent by maintenance, allowing you to achieve higher productivity and less downtime. In summary, but don't go yet, there's a big opportunity to automate certain tasks your maintenance teams carries out and be in better control. And in this webinar, we will have a look at what is possible and how this can make your business more attractive for existing and also new hires in the maintenance department. I'm Jules Oudmans presenting to you today, and I have a background in AI starting in the 90s. And I've been involved many times in the past 25 years in prognostic and predictive programs that ensure asset integrity for critical assets and critical processes. And I have a mixed background in physics, mechanical engineering, and computer science. Um, and my motto is alike the famous coffee one, digital, what else? A short introduction, a brief introduction on UReason. I work at UReason. It's a software company that provides solutions for real-time condition-based, predictive and prescriptive maintenance, and I help our customers daily to use our software from data analysis to the setup of applications and solutions that monitor important assets and processes. At UReason, we combine our domain expertise and software knowledge with our customers, and I help them from data to solutions. We have offices in Rotterdam, which we see here in the pictures, and in Wokingham in the UK. And our customers are predominantly in the manufacturing and process industry, and the majority of them is located in Western Europe and the North Americas. Our software, APM Studio, is used at different levels in the automation pyramid. Embedded, for example, typically with OEMs, monitoring faults and risks in isolation to the asset. And an asset can be instrumentation, actuator, pump, compressors, filters, etc. We also run at the edge, same software capability, processing asset data of one or multiple assets to run condition monitoring and predictive applications near to where the data is generated. And we also work at level 2 and 3, where APM Studio is used to monitor faults in relationship to the process, deployed or running on on-premise compute. But we can also go all the way up to level 4 and level 5, i.e. operator cloud, open operator clouds, where APM typically is used for optimizing the maintenance cost and planning associated to an asset base that supports your processes. UReason, as I already explained, is active in the field of real-time condition monitoring, predictive and prescriptive maintenance. And our field of operation is from helping customers to insights into data to helping asset owners, OEMs, and maintenance service organizations with data-driven maintenance solutions. Often we start together uh, with our customers to define the business cases and use cases to focus on, followed by data collection, model development, and deploying the solutions into the existing OT and IT landscapes. We work and deploy our software APM Studio for manufacturing companies, and this is about 40% of our business. And we work a lot with OEMs and skid builders. For the OEMs, their focus is to maintain margin, provide data integration, new services and business models, and staying relevant for the customer. And they typically focus on the value of the asset. For asset owners, their focus is to lower energy costs, reduce plant maintenance, reduce reactive maintenance, stretch asset life, or balance the risk and optimize planning for an asset base. Um, for asset owners, it's all about the value of the asset that is supporting the process. So the topic of today is to show you how you can reduce the time spent by maintenance. Now, when you go online and search for this, you will come across a number of usual suspects. And stay with me, as these are things most of you already know, and it may be boring this next minute. So computerized maintenance management systems. Everyone probably has one. They allow you to streamline your maintenance operations, work order, alignment, asset data, spare parts, etc. There's nothing new here. It's all about the structure. and processes to support your field services teams. Planning and matching the work for the available people is important as well, but of course, also something you already do. A more interesting subject is effective root cause analysis and failure mode analysis to close the loop on the work done outside and improve. Here, a CMMS can be of great help if you log a problem, its calls, and the remediation information. But we find often that the CMMS is used as an asset register, what is where and what is it, and as a ticketing or work order system. And then there's the other usual suspect, training. Skilled technicians work more efficiently. I mean, nothing new here either, right? The usual suspects in our eyes are all about improving what you already have and focus on creating a faster Formula One pit stop team. You can optimize only as much as possible on what you have. Henry Ford had a nice quote on this, which basically drills down to the issue industries often face with, which is not thinking outside the box. And it wasn't actually Henry Ford that said this. It came from a Puck cartoon, as you see here in the picture. But I like the quote, and everyone knows Henry Ford and not Puck cartoons. So we endeavor, and we will continue to do so, on a different path where we show the industry, asset owners, OEMs, what is possible with what they already have but do not see. It's not my favorite person and company, but I will quote him. Steve Jobs, who understood very well that you have to show people to convince them, and this is what we do on a daily basis with great passion and motivation, of course. Because there are other ways to reduce the time spent by maintenance on the asset base. I call them the forgotten ones in this slide, but you could also call them the unseen ones. Um, the first forgotten one is the data that is already available in your process historians or logs. This data contains the context in which the assets are used. If you have alarm and event data also available and work order data from your CMMS, this is a really good start that can already yield good results. You may not be able to detect and monitor all fault mechanisms of your assets, but it's very often a good start. In addition to this, you can tap into the data that is available but unused and often not unlocked. Most of your instruments, actuators are capable of communicating diagnostic information, which is often overlooked or only consulted in manual inspection rounds, for example. Irrespective of the communication protocol of your smart diagnostic devices, of which you may have many, they communicate a so-called Namur 107 status, which we see on the right-hand side in the slide. And this status contains important information that allows you to reduce visual on-site inspections and improve the time and the efficiency of your maintenance department. Now let's have a look at the different functions that you will get from this traffic light with 6 colors actually. Um, One of them that's quite important is this orange color, the check function. It's sometimes represented as an orange color in your devices. Sometimes it's represented by this triangle with the wrench in it, or by the triangle with the wrench in it and the orange color. So different vendors either adopt the color, the symbolic representation if they have a monochrome display on their devices, or basically the icon in combination with the color if they do have color displays. Now, check function is a lower severity event that indicates that the signal from your actuator or instrument was temporarily invalid. This could have multiple causes, and especially when it happens multiple times, it's something to check out. Maintenance required, which we see at the top of this picture in the blue color and with the oil can, indicates that the instrument or actuator will have a function drop very soon. So it's actually information from the asset that you can use to optimize in combination, for example, with check function, the time spent at the assets. Out of specification, the yellow one, is also quite important. That means that the device is running outside its permissible range, and as such, it cannot properly support the function it is required to provide anymore. And of course, failure. failure, red, indicates a malfunction of the instrument sensor or actuator, which actually could mean you're actually too late. But if you only do inspection rounds, you may lose out on the out of specification, the check functions, the maintenance requires, etc. You could do things a lot smarter than that. Now, let us consider your maintenance strategy. But before I do, let me first explain the graphic that we see on the slide. And let me take a sip of my coffee as well. The graphic is an asset degradation curve called PF curve in most literature. And at the start, when my asset is brand new, asset performance is optimal. And over time, it degrades because of wear and tear, um, fouling, improper usage, etc. At some point in time, performance disruptions will start to occur, and the likelihood of failure, rendering your asset unable to support your process, um, is quite inevitable. Now, for certain assets, this is acceptable. You may have a redundant N+1, N+2 setup, little to no process disruption, and spares in stock. In this case, your strategy will be reactive or run to failure. Um, and you don't have to do anything, or you don't do anything until the failure occurs. And when it occurs, you replace it or you perform emergency maintenance. If you follow the maintenance instructions of the OEM, or when you have a lot of experience with the asset failing and it is not so critical, you run a preventive maintenance strategy. You do nothing up to a certain point when scheduled maintenance kicks in, which you may either do too early or too late, and you may still run into failures depending on your maintenance activities. Now, another way to monitor your assets is to monitor the data coming from the assets, monitor the data that provides this diagnostic information. And here we talk about a predictive maintenance strategy, where you also use the data and the degradation models to estimate and predict when the asset is about to fail, such that you can schedule the intervention and provide on-time maintenance without losing production. So you can resume production, as we see here in the graphic. Now, if we advance on predictive maintenance, there is the prescriptive strategy, where, alike predictive, you continuously monitor the health and when needed, you schedule maintenance, similar as predictive, providing support to the field worker. And this allows you again to provide on-time maintenance and have minimal disruptions with maximum knowledge brought to the personnel. You probably have seen a PF curve and the different maintenance strategies that I showed in the previous slide before, but nevertheless, we experience on a daily basis with our customers and new customers that there is a gap between maintenance operations and operations. We see that maintenance will have to change and to become more OT driven. And at the same time, we need to bring more knowledge to the worker at the site and use the data to provide decision intelligence and automated root cause analysis. We also see a new rise of tools that will be of assistance to you if you are not already adopting them, supporting the connected field worker out there. Now, automation of inspection tasks, which we're talking about here, and continuous asset monitoring provides solutions to mitigate the consequences of an aging workforce, or to mitigate difficulties in attracting technical people, or difficulties of course also in retaining technical people. And this is an issue that we see especially in Europe and Western countries, where the maintenance workforce is quite knowledgeable on their assets. Very often they grew all together. They have a lot of process, operational asset knowledge, and they've seen automation being introduced in steps over time. And they of course have a lot of skills, a lot of experience, and they will go at some point in time. At the same time, we have a new workforce coming in that wants to uh, only work at a certain site or at a certain location for X number of years, shorter period of time, not the 20, 30, and 40 years that we've seen with the aging workforce. And yeah, they want to have a career, move on to other positions, etc., etc. So it's difficult to retain those people, and this is an area that you need to take into account, and where you can also use decision intelligence to uh, provide more context, more information to those maintenance workers. There is, of course, a legal perspective. Some legislation and regulation actually discourages automation of periodic inspections. Um, at the same time, the argument against it, automation reduces the human error, and it provides a continuous insight in safety of operations related to asset health supporting the functions of your process. So, although legislation, regulation may discourage, in certain cases, automatic inspection, what you could do very often is to lower the frequency at which these inspections take place and make use of the available data from your actuators, instruments, from your equipment out there in the field, the diagnostic data, such that you can still um, do continuous monitoring and move from a preventative maintenance schedule to a predictive and maybe even prescriptive one, where you provide the resources, personnel in the field with the right advices. Now, and this is a short webinar, and I'm looking at the time, so 2 minutes left. I have a summary slide, and then we have some Q&A time. Now, to summarize this short webinar, you can greatly improve the time spent by your maintenance by using the data that you already have, data that is stored and available, but very often untapped. Um, this data allows you to move towards predictive and prescriptive maintenance schemes, where you can monitor the health of your assets continuously, predict events, provide support to the field, provide on-time maintenance, and not have any breakdowns, where you operate in a more reactive mode, so you can go towards a proactive maintenance scheme. Secondly, because of the changes that we will have in our workforces, because of the tools that are available, maintenance processes will change, and we can't continue, in summary, to grow all together with our installations. It's impossible, and we need to become and work much smarter, also in the maintenance industries, operating our assets at the optimal, and trying to automate as much as possible of the tasks, making your processes more efficient and allowing you to attract and retain skilled and experienced personnel. Um, Now we're going to the Q&A session. So I'm gonna open up the session for questions, and you may have already sent questions to Carlos and Arthur, who are the moderators in the webinar today. I've completely forgot them, but Carlos and Arthur are in the background online moderating this webinar. And let me just check in with Carlos, and also on the questions. I have a number of questions listed here for me, and let me start. They're numbered for me. You don't see this on the screen, but the first question that came in is, uh, uh, I'm not seeing who actually sent the question, but do you also provide an option with your software to automate the inspection tasks if I have Natillion from Anderson Hauser? Yeah, so Natillion is a cloud-based platform that allows you to unlock, for example, diagnostic data, hard data from your asset base, instruments and actuators, to the cloud. And we provide a connector with APM Studio that connects directly to Natillion and provides the automated reasoning, but also interfaces to your CMMS systems, to SAP, to Ultimo, to Infor AAM, to Upkeep, for example, that allows you then to automate the reasoning on the diagnostic data, on these Nomur 107 statuses and the other diagnostic events that the assets are generating, and close the loop on your maintenance management system. So automate the inspection tasks and continuously monitor the assets on the basis of the data that arrives in Atelier. Um, I have a question from Laurens. Can you explain again how you can use data from devices in the field for status and health monitoring? Yeah, so data in the field from devices, irrespective of the communication protocol. So if you have analog 4 to 20 milliamp devices with hard, or if you have Modbus, Profibus, Profinet devices, all of these devices also communicate diagnostic statuses, not at the same rate as they do with the process values or the returns to the control systems, to the SCADA DCS systems. These diagnostic values can be unlocked, or we unlock them very often via a secondary path, not to burden the automation pyramid with the network traffic that is incurred by reading this diagnostic data. So we apply what is called a Namur open architecture to do this. Um, the big advantage of this is that we do this in a very secure fashion. It's industry adopted. We can do this with multiple vendors, with Vago, with Phoenix Contact, but also with other vendors as well. Do it on-premise, on edge compute, near the assets in the control cabinets, but also provide the capability of reasoning on the diagnostic data from the field devices to higher level systems, higher level in the automation pyramid. I have a question from Emil. Can the content of the webinar be read somewhere? Oh, good question. After the webinar, we always share the presentation slides. So we share the slides, plus we also provide a recording. And let me check. Maybe I'll ask Carlos to check with you if you also want to have a transcript. That's also possible, of course, of the webinar. And I see the Arthur saying it's answered, so super. Yeah, let's see. Now I have a question from Paul. Now I can see the names. I was in the wrong chat window. I have a large number of actuators at my site from both Rotork and Alma. How can you reduce inspection times on these? Okay, so Rotork actuators that have a top of my head a PEC scan card, which is very often included by standard in the Rotork actuators, can communicate their diagnostic values, a lot of values actually from Rotork to a master station of Rotork. And this master station provides Modbus TCP interfacing to which we can connect. So for Rotork actuators, we also work with Rotork. We have a lot of experience with those, both on the OEM side, but also on the asset owner side. Alma is much the same. I have to think. I can't top of my head think of but they have an edge computer that allows you to unlock diagnostic data from the field devices, from the Alma actuators in the field, and they're in the same way as with Rotork. You can unlock the data and provide insights on impending failures of your actuators, which could be motor related, gearbox related, could be related, for example, to fouling buildup that you have in the pipe for which the actuator closes or controls the valve. Could be related also to valve issues with respect to the liners. So there's a multitude of different solutions that is possible there to reduce the inspection times and to use the data from these devices on-premise or also in cloud. Um, Let's see which question from Wouter Geubel. Oh, sorry, I shouldn't mention the surnames. Sorry about that. From Wouter, a question: how do you typically start with a customer? So we typically start with a customer, and I could go back in the slides, but I'll do it verbally if that's okay with you. We typically start by identifying critical assets for a customer. So if a customer is an asset owner, we typically start with identifying the critical assets. And for the critical assets, collecting process data from their historians, from their logs, work order data, alarm and event data, and on the basis of this, we determine if this data is sufficient to build degradation models with for that specific customer. Not everyone stores every data point, every data element that is coming from their assets. On the basis of that first analysis, we provide a solution path where we sketch what the added benefits would be of doing APM on those critical assets. And that solution path also includes the software, hardware, if needed, that the customer requires. On the basis of that, we take small steps. So we typically, let's say there is 3 or 4 different types of assets, control valves, e-motors, pumps, and let's say heat exchangers. Then we typically try to focus on a group of assets and roll out in a stepped based manner, such that you have quick results and you can also involve maintenance department operations on the successes of those quick results and adjust the work processes, organizational procedures, etc. I'm just checking with Carlos and Arthur. Did I miss a question? And I'm just checking. There's no more questions. Did I miss one? I think we answered all. I'm getting the positive feedback also from Carlos and Arthur. Um, I would like to thank all of you. So all the questions have been answered. If you would like to get in contact with us, of course you can do so via the website, etc. But on this page you also have my email address. I would like to thank you again very much for listening in and asking the interesting questions. After the webinar closes, you will get a feedback form. So stay online. We really appreciate your feedback. If you have had to leave already, Carlos would have sent you a feedback form as well. And I hope you enjoyed it. And I wish you all a nice day. And maybe we'll see you again in one of the next webinars. Take care, everyone. Bye bye.